Greetings, the Astro 30 here yet again, looking at this simple power amplifier again. Now, this is going to be more of an update video. Now, in the previous video of the frequency response of this, I noted that the upper limit started rolling off around about the 4 kilohertz mark, and an astute viewer in the comments mentioned something rather, well, I find valid. He said, remove the 470 picofarad capacitor, which is the one that goes across the base and ground of the first transistor of the long tail pair, and that does have merit. It may be causing an issue with the upper frequency response limit, so we could try removing it and see if that improves the upper end frequency response, which is all I'm really worried about. And I will say this now, if that works, I'll shave off my beard. And I mean that. So let me set up a power supply again for the 1500th time. Dummy load, oscilloscope, function generator, well, audio generator, and yeah, let's get cracking. Alright, circuit's powered up. Haven't removed the capacitor yet. Okay, we've got the reduction. So I'll just carefully remove that ground connection. Put it somewhere out the way. Still decreasing. Has nothing to do with that input capacitor. So there you go. I don't have to shave my beard off. Alright, so what does this mean? Well, buggered if I know, to be honest. So it makes no difference whether that capacitor is in circuit or not in circuit. So, okay, I'm using this trem pot as an attenuator. So I've got my output set to around about 1 watt. The input capacitor is removed. So that's at almost 20 kilohertz. We got 4.7 out, so we dropped, I want to say, a volt. If I plug the capacitor back in, which I missed, look how much further that voltage dropped off. At least another volt. The dude's right. I also changed that capacitor in the feedback network from 100 to a 47 microfarad. I don't know if that made any difference. I don't think so. So I'll just take this out of circuit. Nothing untoward should happen. I'm going to plug the 100 microfarad back in. Just verify. There we go. That 100 microfarad has made it reduce. No, because my 470 is still plugged in. Nope, doesn't make a difference. That capacitor is fine. However, the 470 picofarad is not. So, okay. Oh, shit. Looks like I'm going to have to do it. Ta-da! I don't lie. Man of my word. I guess he was right. Well, it kind of makes sense, really. Well, I did promise you, and I did it. It's not much of an improvement, but it's a little bit better. I'm quite alright with that, because we're at almost 20 hertz, yeah, about 20 kilohertz. It's only dropped off a volt, so it should sound a lot better in a speaker. I've also got the dummy load connected directly to, well, the center of the filter caps over here. I don't know if that's making a difference to the frequency response. I can verify that by putting it back up to the 20 kilohertz mark. It's about there. Remove the load from the power supply, connect it directly to the circuit. Actually, voltage came up a bit. Right. Well, that looks like a much more respectable frequency response. I want to know what it is at the 1 kilohertz mark. So, alright, well at 178 hertz, it's roughly the same voltage, so that's not too bad. So I'll go back up to 1 kilohertz, which is somewhere there. Probably a little high. No, we're only halfway there. Right, there we go, we're at 1 kilohertz now roughly. It's about the same. Thank you to Jeff Hooker, who was the original commenter in the last video about this capacitor. It does actually make a difference. I'm going to take that out of circuit so it's not acting as an antenna picking up noise. So everything looks pretty good now. I will stress I didn't connect the ground connection to the trim pot here, and this 10 ohm 1 watt resistor started heating up and burning up. I could smell smoke coming off of it. That's because the amplifier went into oscillation. That was after I removed this 470 picofarad capacitor off the input from the ground, and it started to oscillate. It's only because it was picking up a shitload of noise and everything, and this was not grounded. Oh, and why, you may ask, am I measuring the frequency response at 1 watt roughly thereabouts? Because that's normally where power amplifiers frequency response measurement is measured. It's measured A-weighted at 1 watt into 8 ohms. Not that I think that this little oscillator is A-weighted in any way, but A-weighted is just meaning the same as our hearing because it's logarithmic. It has a certain filter curve to it to match the conditions of our human hearing. Alright, got the speaker plugged in down there on the floor. I'm using those 2 binding posts just so it doesn't accidentally pull the wiring off the desk and the whole entire thing. I'm going to leave the attenuator in circuit. Why not? That's interesting, there wasn't that much of a turn-on transient there. But there is a bit of a weird buzz. I reckon that's just circuit noise more than anything else. Turn the volume down. It does sound a lot better. Alright, I'm going to take that attenuator out of circuit just to make sure it's not that's causing the weird noise on the output. The attenuator's out of circuit. Interesting. That sounds a lot better actually. That tweeter sounds like junk. Not sure why either, but it sounds absolutely terrible. I know it's not the circuit doing it, because I did actually try it and made a few little play arounds here and there. But I tested it on this junk G5 guitar practice amplifier. Unfortunately, I've inadvertently mucking around with the circuit board, I've blown the speaker in there, because it smells like burnt electrons now. So, in a word, that speaker is So I'm leading to believe that there is something wrong with that tweeter. However, the good news is the circuit did perform okay on that smaller speaker. Sounded okay to me. Didn't sound like it does on this. So there's something wrong with the tweeter, I reckon. But the DC offset is quite amazing too. I've gone back to the original 1K5 that goes between the collector and the negative. And yeah, it's fine with that value in there. But the sound of that tweeter is just terrible. And I guess the other good thing is there is no turn on transient now, which is wonderful. So with the multimeter connected across the output, it's currently unplugged, so ignore that reading. I'm going to connect the supply, and look at that, it buggers off almost to 0. That is awesome. Put that on millivolt scale, and well, we've got about 7.8 millivolt DC on the output. The input's still connected, so if I disconnect that, it changes a little. So yeah, that is a perfect DC offset, I must admit. So apart from the speaker's tweeter not sounding right, which I believe is the tweeter, I know the frequency response of this amplifier is better. I also know that it sounds okay on a different speaker until I blew that up. So I'll go ahead and make the change on the PCB by removing that capacitor. It's no longer needed. So yeah, thanks Jeff, you pointed out the obvious. So anyhow, I'm going to close this video out here. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below. And you can also become a Patreon supporter for as little as $1 a month. And or you can follow me on Facebook. Links are in the description as usual, guys. Anyway, this is the Astro 30 saying see ya, have a great day.